लेकिन मेरे को आ रहा था, मैं स्टार्ट कर दिया रिकॉर्डिंग।
ठीक है सर।
ठीक है, इट्स रिकॉर्डिंग, वी कैन गो अहेड। या
वैसे यार एक दूसरा ऑप्शन भी था, मैंने अभी स्ट्रीम यार्ड चेक किया ना, तो स्ट्रीम यार्ड में मेरे को आया मतलब ऑप्शन लाइव स्ट्रीम करने का। तो उसमें क्या होता है ना, डायरेक्ट यूट्यूब में आ जाता है फिर सब कुछ, हमको मतलब कहीं अपलोड नहीं करना पड़ेगा, कुछ नहीं करना पड़ेगा।
सेटअप टाइम होगा राइट? अभी
क्या
अभी तो स्टार्ट कर सकता है इमीडिएटली, या सेटअप उसमें कुछ टाइम होगा, वार्म अप टाइम में कुछ?
मैं तो इमीडिएटली स्टार्ट कर सकता हूँ यार, बट मतलब फिर मैं एडमिन बन जाऊंगा ना। मतलब तू ट्राई कर अपने तरफ से, तेरा भी हो जाएगा वो इमीडिएटली।
उससे क्या ऑफर पड़ता है एडमिन से? जस्ट ट्राई कर, अगर हो सकता है तो, अदरवाइज वी विल जस्ट स्टार्ट, विल सी नेक्स्ट टाइम।
हाँ ठीक है, फिर नेक्स्ट टाइम देखते हैं वो। मतलब वैसे तू देख लेना, मतलब वो इजी है एक्चुअली। मतलब बस उसमें ना लाइव स्ट्रीम शेड्यूल करना पड़ता है, मतलब करंट कर दो उसको तो अभी हो जाएगा वो, मतलब वो।
ठीक है ठीक है, आई थिंक लेट्स स्टार्ट। सो आई विल जस्ट शेयर हियर।
ये कुणाल अलग से सेट करना पड़ता है जेमिनी के नोट्स टेकिंग के लिए? मतलब लास्ट मीटिंग में अवेलेबल नहीं था, बट इसमें है शायद, है ना?
मैं समझा नहीं सर, क्या पूछ रहे हैं?
इसमें अवेलेबल है कि जेमिनी इज टेकिंग नोट्स, इस प्रीवियस मीटिंग में अवेलेबल नहीं था, ये अलग
नहीं,
से
वही तो वो फाउंडेशन ने स्टार्ट किया ना, वो आपको एंटरप्राइज में अवेलेबल है राइट? वो फ्री अवेलेबल।
ओके ठीक है।
ठीक है, सो वी विल स्टार्ट विद टुडेज एजेंडा।
ये इसमें कुछ स्टार्ट करना है क्या? मैं नोट लेने वाला कुछ करना है क्या ऑप्शन कुछ?
नहीं, ट्रांसक्रिप्ट ऑन होगा ना, ट्रांसक्रिप्ट और ये दोनों ही ऑन होगा राइट? रिकॉर्डिंग।
ओके, कॉल रिकॉर्डिंग ऑन है, ट्रांसक्रिप्ट ऑन कहाँ से चेक करना है भाई? ये
और नहीं, नोट ले जेमिनी
सर, ये
नोट
ले रहा है, लिखा हुआ है इसमें जेमिनी इज टेकिंग नोट्स। टॉप
लिखा हुआ है?
टॉप लेफ्ट राइट।
हाँ लिखा हुआ है, करेक्ट है, करेक्ट, श्योर।
Okay, I think so. My screen is visible. So let's start. So the agenda for today is fundamentally to go over intelligence itself. Machine learning is basically about intelligence. So intelligence is these are the things, some of the things that we will be covering today. Intelligence, then symbolic AI, machine learning. Then there are what are the kinds of learnings which are available, what neural networks, and predictive, generative, vision, different kinds of AIs which are there, LLMs, and then what is the foundational math. So basically we'll focus on this. ये सब तो थोड़ा theory हो जाएगा, but the idea is to focus on what is the foundational math for machine learning. All right. So we'll start with the agenda. So agenda में I think so this is basically from the feedback from last call, right, Brijesh, that we connect everything top down, that why we are particularly focusing. Because अगर मैं if I straight away go to the math stack and then start talking about, let's say, all the gradient descent and linear regression वगैरह, then the question would be, are we really interested into even learning that, right? So the idea was that you connect top down, that why certain thing is significant, and then maybe we'll be able to appreciate the importance of it, right? And maybe support that with a use case, that why a because maybe all of us are not ML or AI engineers, so it's not directly applicable to our job, at least the very, very fundamentals level things. So so if we connect it from top down, maybe then we see the importance of it, right? So intelligence, if you see, intelligence is basically an ability to perceive, learn, reason, and act towards a certain goal, right? This is a kind of a theoretical definition of intelligence. There are two kinds of intelligence: biological intelligence and artificial intelligence. Biological intelligence is something that all of us are exhibiting right now. So all of us are exhibiting right now biological intelligence. Biological intelligence basically comprises of reasoning, language, vision, planning, and learning from experience, right? So these are some of the traits of biological intelligence. And why this is important is because artificial intelligence is just trying to simulate that, right? Through the fields of AI and ML. It's trying to simulate that intelligence and then trying to learn that, okay, how a certain intelligence is happening in biology, is happening through life, and then trying to basically arrive at the fundamentals of it, try to figure out what is a single, let's say, learning algorithm which for intelligence, can we arrive at that? And that would be an over goal. And that will allow us to basically learn about learning and then maybe make machines itself intelligent, right? So that is the uber goal of intelligence as a field in computer science. So, so it's important that we capture that there are different kinds of ways of biological intelligence and how we can learn from biology and then adapt that into animal intelligence, into the machine intelligence, right? So basically, animal intelligence exhibit these kind of properties: perception, instinctual behavior, and then learning. These are the things that animal intelligence or biological intelligence basically exhibit, right? And we have to learn from that, right? So and how does the biological intelligence? ठीक है सर, मैं कर रहा हूँ फिर. I shared it here.
अभी शेयर नहीं लोगों से. हाँ ठीक है, फिर नोट्स नहीं लेना पड़ेगा ना.
नहीं, I shared in that. I think आपको भी दिख जाएगा. Shared with everyone.
मिल गया. Sure, go ahead.
So just looking at how biological intelligence itself has evolved, because that will help us or help basically computer scientists and artificial intelligence scientists to basically incorporate that into machine learning, right? So biological intelligence, basically, maybe it was born 3-4 billion years ago when life itself evolved on Earth, right? So life, basically the single cellular or multicellular, very early life, they started looking around and then trying to understand the surroundings, the environment in which they were, and then they were trying to, based on the stimulus, they were trying to adapt to certain response to that, right? And based on the stimulus and the response, they were able to learn some patterns about the nature, about the surroundings, and then that built certain mechanism inside them, which basically made them an intelligent being over a period of time, right? So this is so what we see is there is a stimulus and then there is a response to that stimulus, right? So this is kind of a supervised learning, right? That what you do is that you say that okay, this is an input and this is the output or label, and then given that input, maybe billions of time, a machine can also learn to basically predict different given a fresh input where output is not available, maybe it can predict the output, right? So this was kind of very analogous, which maybe scientists try to bring that thought and how they related biological intelligence to machine learning. So this was how maybe it was adapted. So this was basically biological intelligence was adapted by God or by the surrounding, by evolution. And then the artificial intelligence, the same thing biological scientists will have to do in the current era, so that they can make even maybe machines kind of a similar level of intelligence, right? So machine learning is now coming to ML. And machine learning is systems that learn patterns from data, right? So this is the core definition of machine learning, that it can learn patterns when you give a large amount of data or huge amount of data. It's critical that the data should be used, then only it can learn those patterns. And what are the classifications of machine learning? So there are primarily 3, and then self-supervised is kind of a supervised learning itself, but people also see that there are 4. So one is supervised learning, unsupervised learning, self-supervised, and reinforced learning. These are the 4 kinds of machine learning. I think this from here, I think maybe we have some understanding of this based on our background. So supervised learning is again regression and classification. There are 2 kinds of supervised learning. So we will see that from these things, I think we will see in detail that what is regression, what is classification. Regression, basically linear regression. I think यहाँ से थोड़ा सा idea होगा. All of us, we have mathematical background. So this we will know about this. Classification is, so just a very high level idea. Regression is kind of predicting a number. So you are given an input X and then you predict what will be the output Y. So this general pattern is called regression. And then linear regression is basically a linear equation, right? So you say that y equal to mx plus b, right? That we all have learned about this. And this will be a very linear graph. So given a lot of training data, can you put that and plot that in a graph? So you have, let's say, a certain set of training data, and now you are able to plot that in a graph, and then you are able to see that this is a linear trend. Now, given some input where you don't have an output, you can predict that what will be the output of it, right? This is like if you plot, it's like plotting things on a simple line, right? I think we can all relate this using our maths background. So this is regression, and we will see more detail. This is just to give an idea on it. Classification is basically so classification is a problem in ML where you classify, you don't predict a number. Here you say that, okay, I want to classify this as into one class and other class, right? So simple problem could be that given, let's say, a tumor size, you predict whether the patient has cancer or not. So you predict 0 or 1, right? So it's a binary classification that we are doing. So there could be, let's say, a lot of images are thrown, and you have to predict whether the image is a cat or images of a dog, right? So these are kind of a classification problem. So this here you predict class of outputs or group of outputs, and in regression you predict basically a number. So regressions are different kinds of regression. Will again classification, we will see that. Then supervised learning is built on. So what is supervised learning, right? And what are the supervised learning? You will see that under supervised learning, we will cover all these things: linear models, probability, loss function, gradient descent, and regularization. So all these topics we will go through under supervised learning. Unsupervised learning will not go that much. And just to clarify, so 90% of the ML that we see today is all under supervised learning. So 90% of output, or basically the research, everything, LLM, all are primarily under supervised learning, and that is the major focus area. Unsupervised learning is basically clustering. So what we say is there is no output label which is given to the machines for the unsupervised learning. What is said is that, okay, these are the data, right? And since there is no output label, what machine can do is it can group them into clusters by just looking at the properties of those data itself, right? So maybe let's say you have, I'm just saying, right? You have employees data, and then you can group them maybe into different departments. So this could be clustering, or one example. Or maybe you have e-commerce products, and then you can classify them into maybe all the shoes, because all the shoes will have one class of property. Shirts you can classify separately. Maybe a different home decor product you can classify separately, right? So that would be an example of unsupervised learning or clustering, where you only give attributes, and then you basically say that, okay, this is one group, this is another group, just based on that data. So that is unsupervised learning, clustering, and these are some of the algorithms. So these I am not planning to cover, and because those were not primarily, I think, in courses also, I didn't see people focusing on this, and didn't see that much important, but primarily could be of interest to anyone. Then self-supervised learning and then reinforcement learning भी उतना ही cover नहीं करेंगे, but just to touch upon it, LLMs basically do these two things also: self-supervised learning and reinforced learning. Self-supervised learning is kind of a next token prediction, right? So you will see that what LLM primarily do is they will take the user input, and then they will say, so for example, if we take a sentence like I looked at the road and then crossed the road, right? So if I say a sentence like that, or cat saw a signal and then it crossed the road. So if we say a sentence like that, what we are trying to figure out is, let's say I can obliterate any one word, remove any one word in that sentence, and then what LLMs primarily do is they will try to predict that particular word. So in that sentence, they will try to find what that word could be, right? And how they do it is they will have list of probabilities of all different words which can come to that position, and they will pick the one with the highest probability. So LLMs are primarily supervised learned. So you give them enough data with labels saying, okay, this is the input and this is the output, and then you train them with, let's say, just internet scale data, and then you finally train them on this token prediction, where you obliterate one word and then you ask them to predict it. So they will try to predict. So this is primary class of self-supervised learning, which LLMs do. And then reinforced learning, again, not basically trying to focus on this, because this is also a very different class of problem. But reinforced learning, mein one aspect which is very important is RLHF, which is reinforced learning and human feedback. And why this is important is that if you ask LLM can give the output in any way, in any format. In any kind of output it can give. Maybe the output could be very harsh, and it could be dishonest output. It can be a joke, or it could be it can offend the person also, right, who is discussing. So what is primarily done is using reinforced learning and then human feedback. LLMs are again trained to give a certain kind of output and not give certain kinds of output. So this is RLHF. So which is I think I see an application in the LLM era from the reinforced learning side. Otherwise, mostly these are, I have not seen much of application and not planning to cover these algorithms in detail again. Yeah, so moving on, I think, so now just looking at what kind of AI is there, right? Again, taking a step back and then looking at this. So AI, you can see that there is predictive AI, there is generative AI, computer vision, speech AI, and decision AI. And there could be maybe more also to this, but primarily the trend that you see is of generative AI, which is the LLM side of things, which is getting focused right now. But this trend may shift, and then maybe something else. Maybe computer vision will become more important, or something else may become more important tomorrow. Generative AI is currently more important because there is a lot of data on the internet, and then because there were a lot of amount of data available as a training data, it was used as a supervised learning, and then LLMs have become an application of it as this. But those are not primarily, if you just think about intelligence itself, and to make machine intelligence, it has to go into vision intelligence, it has to go into spatial intelligence, and all those fields also, which would be maybe something which scientists are doing right now, or it would be more trend in future. But if you want to primarily make machines intelligence, you'll also have to go into those areas, not just generative AI. So generative AI may, I think it could be text-based, which is LLMs we are already seeing. Images also we are already seeing, like Google Nano Banana and all. And there are different images models which have also come, where you can give a text prompt and then it can generate images. Audio, I have not looked at much, but there are audios also can be generated very easily using the same text trained data which is available. And then LLMs can be multimodal, which can work across text, image, audio, and even video. Right. So now coming to large language models. So tokenization, embedding layers, transformer blocks, attention feed for work. So yes, there are some aspects to it, and some of them maybe we'll go through that in the next week, on subsequent weeks. LLM training, I think this we have already seen, these three aspects of LLM training. Now, just to give an overview of the mathematical foundations. So first is basically linear algebra, probability. Then it's linear models. Then logistic regressions, loss function, gradient descent. Then comes neural network. So neural network is basically you combine all of these and then it becomes a neural network. And then transformers actually solved neural networks. So transformers are also neural networks itself, but they looked at certain problems. So maybe RNN and CNN, and then transformers actually solved them. And then that's the reason LLMs are there. This also we can look at in detail.
Kunal, isme ye jo hierarchy that you are showing, so you, like for example, linear algebra plus probability, so that is used in linear model. मतलब कैसे read करूँ? I should read.
Yes, sir. Yeah, this is most fundamental, right? And then you build on this to this, and then this is how you build on, right? And then you maybe यहाँ पे, and then you reach maybe LLM stage, right?
This is how these nodes connect together. Yes, start okay. Everything is used right from the property.
Yeah, right from top. Everything will be used. Yes. Okay, so now I think this all we have looked at already, machine learning and all, again, the classification, same thing. So I'll just skip over this. Maybe we can look at So this was, I was referring to 90% of value in ML is driven by supervised learning. I was saying 90%. So this is more, in fact. Given you learning algo, correct the output. So supervised learning is nothing but learning from a mapping of input and output. So you are given, this is the input, this is the output. Very simple, like just a map of input and output. But the idea is that if billions of inputs and output combinations are there, the machine should be able to learn from it. And then when a new input is given where the output is not available, it should be able to predict the output. That is the fundamental of supervised learning. And how this is done, that is the core of it. And then it's, in fact, it's little unintuitive that how can you can predict something by when you can be trained with certain data. At least to me, it was little unintuitive. But when I understood that, okay, what happens inside a neural network, what happens using logistic regression, linear regression, then I was able to relate. But this is definitely a very fascinating idea from that point of view, that given enough data, machine can learn and then it can predict the future data. So one of the classifications just aapko karna hai, right? So for example, spam and non-spam, these are again supervised learning. You have to classify emails as spam or non-spam. But let's say you have to convert an audio to a text transcript. This is again supervised learning, but a different class, which is maybe linear regression or not a classification problem. Then translation and all these things. Or maybe you have to predict that, okay, whether a user will click on certain ad or not. These are all examples of supervised learning. Coming to, I think, classification also, this we have looked at, these two examples. So let's come to regression, right? So, and now I'm going into the mathematical foundations of it. So, I think I will just pause for any questions.
So, Kunal, I mean, so we also have one deep learning thing, right? I think this learning actually based on the deep learning, how, I mean, it actually, currently we had like, previously we had like neural networks with one layer, then how deep learning actually introduced multiple layer actually, right? So like if you are, so I mean, how that will come into picture, this whole thing, right? This is like that is like a basic of this also, right?
Yeah, so deep learning is, I think the way I understood is nothing but it's just more complex neural network. So yeah, so it's just that you have created neural networks. Now your neural network could be, let's say, 3-layer neural network, right? Aapne input diya, then you have one layer which does some processing, another layer does some processing, and then maybe there's a output layer, right? But now you will see that, okay, this can do some basic work, but it will not be able to do maybe advanced work, right? So yeah, and the fundamental basic idea is that if you make your neural network complex, that usme one layer ki jagah you, let's say, add 1,000 layers or million layers, right? And then in each layer also you add a lot of neurons. Then it can learn more. It can you can train this with a lot of data, and then it can predict maybe complex problems.
So transformer is similar to that only, or is like?
So transformer पे आते हैं इस पे उसमें. So transformer में, just to give a general idea on this, you know about RNNs. So let's say so RNNs में what used to happen is, then let's say now these are all part of NLP, right? Natural language processing. So you are reading a sentence. Now when you are reading a sentence and then you are looking at a set of words, so like let's say you are now on the 10th word. Now there is a window till which you can look at, right? So maybe you are able to look at certain window, and that is itself is in your memory, and then you are able to kind of relate to that, right? What transformer allowed is that instead of looking at this particular window, now you can look at the entire context. So maybe your context could be one entire document that you are training with, right? So it can take one word from the document and it can create a mapping of that word with every other word in that document, and it can say how this word is related to that. Each of the word, and based on that, its vector and embedding will be created, right? And then transformer allowed it to be done in parallel. So it's nothing but it's again a neural network, but there are encoders and decoders, both two kinds of neural networks in that, and then it predicts the next word, right? Yeah. So transformers are basically what allowed the current form of LLM to come and exist. Otherwise, with RNN वो possible नहीं था. But RNN से क्या possible था वो we will look at that.
Okay.
Yeah. So yeah. So moving on. So the math part of it, right? So this is very simple idea. So regression is you have to predict a number, right? And this is a simple linear equation that we have seen. So f is a function of w and b. So you say that fx equal to b. So here w is one parameter, and then b is another parameter. B is a scalar, and w is a variable here, right? So you basically train. So this is one equation here, right? So let's take an example of you have to predict a house price. This is I think one of the fundamental problems which is discussed in academics. You have to predict a house price when let's say not location, let's just say area of the location se complex ho jayega, area of the house is given, right? And you have to predict. So you will be given, let's say, a certain amount of training data, and then you train your this regression model, which is fx equal to wx plus b, and then you have to predict. Now, when a new input is given, value of w and b is given, then you have to predict what is the value of x, right? This is from where fundamentally we build things, right? And you will see that, okay, this is at least the idea is taken from here, and this same idea is used in all the supervised learning, right? Whether it is neural network or transformers, हर जगह ये idea use होता है, or any other kind of model, not just generative AI. Even other kinds of models that we use, the same idea is used to basically train the model or network, right? So so let's say, मतलब यहाँ पे मैं लिखा नहीं है, but let's say you say that, okay, this is x is, so on y पे price है, y axis पे, and x axis पे we have the area of the house, and then based on this we plot these x that you see. These are the values that we have plotted on the graph, and then what you have to do is you have to find, okay, what is the common line which basically goes through all of these, and then which can predict the values of y, right? So abhi so you will try to, maybe you can put different lines. So let's say ek ye line ho gaya, and then you can see that, okay, this line is basically catering to, these are all input data, by the way, there is no output data. So the first value, this value, and this value, it's able to exactly cater to, right? But this value is not able to cater to, and there are some places where it misses, right? So maybe you will say, okay, let me draw a different line. Let's say the line is here, right? Now this line maybe is not even catering to any kind of input data. Maybe you can draw just a parallel line also. So that maybe will cater to 1 or 2 data points. So the idea is that what is the line that you can draw which can cater to most of the input data, and not just the input data, but in future, if there is one more square feet of a house given, and then you are able to predict the price for that, right? So I think when a real world data is given, you will invariably realize there is no single line which will fit all the data, and it's very difficult to cater to all the input data even. But what this allows you to do is, and that's not, I mean, the idea is not to even find that particular line here, right? The idea is कि आप cost decide करो कि, so you decide, first is decide a loss, right? So loss is, let's say you took this input data, and then you see that this is not on that line by maybe this factor of this, right? So you take a point here, which is y dash, and then this is the actual y, and then you take a difference of that, right? So yi minus xi. So this is the loss across one input variable, right? So one input or one training data set, this is the loss, y hat minus y. And then you do it across all the training data. And then you find a square error cost function. So this is you will arrive at a cost function. This is a simple, again, a math. So you have, again, to repeat, this is y hat minus y across all the different variables with whatever function that you said, I'm sticking to this function, right? Now you can just do a summation of over it, do a square, and do a summation, and then do an average out. Average out is generally done to keep it in a certain range, just like a scaling or feature scaling. And then, so this JAWB becomes your cost function. Now we will see that, okay, this cost function is used, and then there would be the idea. What is the idea here, right? The idea is to basically make this cost function 0 or close to 0, right? if we can close to 0, that means all our training data will cater to the line that we have decided, right? Or the function or linear regression function that we have decided. All the data will cater to this, right? At least this is clear, right?
Yes.
Okay. So okay, so this is, I think, the takeaway from here is that we have done a linear regression, and then we have arrived at a cost function. And later we will see that how do we basically use this cost function to train the data and to minimize the cost and arrive at a model which can cater to all the training data, most of the training data, and also predict a future number, right? So this is what we have done here. This I will leave because we have already covered this.
So
Now
the training is that we are finding the value of WNB that will actually minimize this whole cost. Right?
So training will mean, you have to find out the WB, but WNB is not one value, right? It will be.
I think
I think yes, that is the goal. Yeah,
basically there is a mathematical function. उसके जो variables होते हैं ना, मतलब जिसके variable है, the constant WB, उनको हम training में ऐसी value assign करने की कोशिश करते हैं. Later on जो मुझे value एक ऐसा कर्व और ऐसा ग्राफ प्लॉट फंक्शन प्लॉट करना चाह रहे हैं जिसमें later on जो values होंगे they also fall on the same graph, so that
तो आपने WN वैल्यू की
they can be predicted later on.
फाइंड कर लिया तो आपको फंक्शन पता चल जाएगा, राइट? यू विल बी एबल टू अराइव एट दिस फंक्शन, and then you will be able to, then given new value of WNB, you will know that what is the value of fx, right?
And these are the dimensions also, मतलब जैसे price, location and all those. अब जैसे in the LLMs we have billions of variables, right? So वहाँ पे billions of variables का function होगा मेरे पास that I'm trying to train basically. That will give me because there are like each variable in a way represents the dimension of data. जैसे price हो सकता है, या location हो सकता है, housing वाले terms.
Features will be more. This is just a simple example taken, but of course, house of price will be decided by so many factors, right? And then आपका equation जो है वो linear नहीं हो सकता. It could be a quadratic or it could be, let's say, a polynomial.
Correct. इसीलिए हम different functions होते हैं. Right. So it depends on functions. लेकिन but we have to somehow determine the value for set the value for WNB by using the training models, so that we are very closer to cover all the future values also. उस तरीके से तो more or less they lie on the same point.
Yeah. So let's say जो आपका जो prediction या जो function है आपका regression का, that becomes, let's say, a polynomial. So it could be W1, W2, W3. Some of them would be W cube, W to the power of 4, W1, and then maybe quadratic, different kind of वो हो सकते हैं. And then the line that you will see, that also will be a more like it could be a circular, it could be a round, or it could be like this, right? Any kind of, whatever is the polynomial, that kind of line you will get on the graph, right? And maybe it will not be 2D also, right? When you have so many W's, maybe 10 or 20 W's, then it can, maybe it's not even possible to draw this also. So, but you can visualize that it would be a very, very complex function. But the overall, the idea is, yes, there would still be a cost function to it, right? Which is कि आपको जो training data दिया हुआ है, उसका आप training data और जो आपने you arrived at certain regression function, right? So you take a diff of that. So what the value that you arrived at is your white hat, and the input data जो आपको दिया, because आप label data है, तो you already have a y value there, right? So you take a difference and square it and then do a mean, and this is the cost of data. So cost is basically what is the loss across all the data set, and that loss, if you are able to minimize it by training the data. Now you will do a training, and if you are able to minimize that close to 0, so that means you have done the training. So that's the training that you will be doing. It's a supervised learning that is fundamentally done. अब इसको कैसे minimize करना है, you have to take it to 0, वो सब देखते हैं अभी. That is.
So I think one thing is that, I mean, so if I want to do this POC on this one, so I need to create certain data, make sure that I'm giving different WB value, try to figure out the equation, and then use that as for other input output. Other you can say examples. So if I want to do the POC for this,
हाँ, so you have to, if let's say you have to do, तो house prices का data आपने collect कर लिया, right? अब 1000 house या 10,000 या जितना भी है maximum data you can get, you do this, and then that you'll have to feed in. So पहले you create one equation out of it, right?
yeah.
And then you basically find out the cost function. तो उसमें भी different techniques हैं, जैसे whatever data you collected, you divide it into different sets. One you say is a training set, and then you take out certain data from that set itself and call it like a validation set. And then validation set जो आपका fundamental equation बना, validation set को use करके देखो कि उसमें कितना is it appropriate, जो भी उसमें loss आ रहा होगा या cost आ रहा है, वो range में है, acceptable है या नहीं acceptable है. But ये पूरा अभी theoretical exercise है, right? अभी इसको यूज करके न्यूरल नेटवर्क बनेगा, एंड देन न्यूरल नेटवर्क इज समथिंग दैट यू कैन ट्रेन यूजिंग टेंसरफ्लो या टॉर्च पीआई वगैरह जो यूज करके करते हैं, राइट? सो दैट यू कैन डू इजीली. सो आई थिंक सो वी विल गो थ्रू दैट इस वीक में नहीं, मे बी नेक्स्ट वीक में वी विल गो थ्रू दैट, राइट? अभी वी आर जस्ट क्रिएटिंग अ फाउंडेशन.
कुणाल यार, इसके लिए न्यूरल नेटवर्क की जरूरत नहीं है ना यार. मतलब ये तो हाउसिंग प्रेडिक्शन है ना. अगर हम लोग टाइम प्रोटेक्शन और ये सब कर रहे हैं, उसके लिए शायद हमको न्यूरल नेटवर्क मतलब बनाना पड़ेगा, जो रिकरेंट न्यूरल नेटवर्क और ये सब होता है ना.
हाँ, मैं ये कह रहा हूँ कि ये थियोरेटिकल एक्सरसाइज है जो आइडिया दे रहा है कि हाउ हैव वी थॉट इवन कॉन्सेप्चुअलाइज की मशीन कैन आल्सो लर्न, राइट? सो अगर आपने एक फंक्शन बना लिया तो दिस इज हाउ मशीन इज लर्निंग, इज व्हाट आई एम ट्राइंग टू से, राइट? कि आपने इनपुट्स के बेसिस पे एक फंक्शन बना लिया, अब आप इसको यूज करके फ्यूचर को प्रेडिक्ट कर सकते हो, राइट? फ्यूचर डेटा को प्रेडिक्ट कर सकते हो, राइट? बट अल्टीमेटली फिर यही सब नॉलेज जो है फीड्स इनटू न्यूरल नेटवर्क व्हिच इज यूज्ड फॉर प्रैक्टिकल और रियल वर्ल्ड यूज केसेस, राइट? ठीक है, तो अब आगे बढ़ते हैं. हाँ सर, ओके. नाउ कमिंग टू ग्रेडियंट डिसेंट. सो ग्रेडियंट डिसेंट को, सो व्हाट इज ग्रेडियंट डिसेंट, राइट? सो अभी मैं बस बेसिक्स बना रहा हूँ. अभी वी टॉक्ड अबाउट लीनियर रिग्रेशन, राइट? नाउ वी आर गोइंग टू ग्रेडियंट डिसेंट. ग्रेडियंट डिसेंट इज जस्ट इटरेटिवली एडजस्ट. ग्रेडियंट क्या होता है? ग्रेडियंट इज, थिंक ऑफ ग्रेडियंट लाइक अ स्लोप, राइट? जैसे अगर कोई हिल है तो इसका जो स्लोप वाला जो पार्ट है, राइट, दैट इज ग्रेडियंट. मतलब लूजली आई अंडरस्टैंड इट दैट डिसेंट का मतलब होता है उतरना, राइट? तो आप पहाड़ के ऊपर चढ़े हो, आपको नीचे कैसे उतरोगे आप? सो बेसिकली you have, based on the cost function that you have calculated across all training data, you are at a peak, let's say. What is the idea? You go to the valley, the smallest valley or the deepest valley, right? Go to the deepest value, and this is the descent that you have to do. And how do you do a descent? What is the mathematical model for that? That we will see. But this is the picture there, right? So iteratively adjust parameters to minimize the cost. This is your gradient descent, right? So gradient descent can be used to minimize any cost function. It can be a linear regression cost function or gradient descent cost function. So मतलब हम gradient descent को we can, so you will see that हम लोग जो classification करेंगे उसमें हम logistic regression को देखेंगे. Logistic regression को भी minimize करने के लिए we will use gradient descent itself, right? So this is little orthogonal in that sense. So ये example, ये graph है उस course में था which I have taken out and put it here. So you are at a slope, and then let's say you are at a certain slope, right? How do you decide कि मुझे मैं peak जो lowest है, जो global minima है, वहां तक कैसे जाऊं, right? गोल तो होगा global minima पे जाना, right? Because you want your cost to be as close as possible to zero. But let's say, so what you do is when you are at a peak, you can take any direction, right? From that, and then just take a small step, a little step, and then see कि उससे cost reduce हो रहा है कि नहीं हो रहा, right? So you have taken a little slope, and then you have calculated again your cost across all training data set, and then you saw that मेरा cost function की पहली जो value थी cost 1 था, अब cost 2 आ गया. If cost 2 is less than cost 1, then it makes sense, and then you can continue in that same direction. But let's say you see that my cost has increased, right? Then you have to change the track. You cannot go into that same track, right? So this is very एक fundamental basic idea है इसका, which we are going through. I think this should be clear, right? So from this diagram. Okay. So what is used here is there is a small this alpha that you can see in this diagram. So alpha is the learning rate, and a small coefficient, learning rate इसको बोलते हैं, which allows you to basically minimize the value to 0, right? And there is a derivative use. Derivative is d by dw when you are, let's say, optimizing for w, and then d by db when you are optimizing for b. हमने दो वेरिएबल का रिग्रेशन देखा था w and b का. The same two parameters we are trying to take a new value of it, right? By looking at this, right? So this is the formula of the new w and b. So what we are doing is there is an existing. So ये w दूसरा w dash मान लो, and ये b dash हो जाएगा. Existing से minus करके हम नया compute करेंगे, and then we will compute again and again and again, and then we keep on checking कि हमारा cost जो है वो zero हुआ है कि नहीं. अगर zero हुआ है या close to zero हो गया, या तो अभी तक increase reduce हो रहा था और अब बढ़ने लग गया, then also it says you that we have reached the local minima, right? At least. So then you stop, right? So वो एक exit rate होगा कि आप वहां से exit कर गए, या फिर आप बोलोगे कि नहीं, I will just do it maybe 100 times or 1000 times, right? You put a number, and then based on that you decide the new values of w and b. So ये आपका इसका मैथमेटिक्स. So ये सिंपल है, ये हम लोग के लिए इज वेरी स्ट्रेट फॉरवर्ड. ऑल दिस थिंग्स, द ओनली आइडिया हियर इज दैट आपको अपडेट साइमल्टेनियस करना है. मतलब यू कैन नॉट टेक कैलकुलेट w and then put into the w b of the same calculating the b for the same step. This should feed into the next step of the w and b calculation. So this is just simultaneous update. So these are pretty straightforward things because we understand programming. All right. So this is gradient descent. इस पे कोई question है before I move on to?
So what I understand from this, right? So I mean, whenever we decide this that function, right? Whatever function we had for the housing price, actually. So whenever we going to train our model, so if you have any learning algorithm, it should use this gradient descent algorithm to actually come up with the proper w and b value, so that the future or whatever in real world, when we are going to use that formula, it will give the right pricing actually. Does it make sense?
This makes sense. Yes. We are trying to find the right value of w and b, which fits most of the current training data, and hopefully it should also be able to guess the right future outputs when we don't have the output given, but we have to predict the output.
Okay.
Right. Yes.
ये लर्निंग रेट वाला अल्फा क्या है इसमें कुणाल, मतलब उसका क्या है?
तो अल्फा आपका सर ये बताता है कि आपको किस रेट से आपको लर्न करना है, राइट? अगर अल्फा की वैल्यू स्लो होगी तो आपको बहुत टाइम लगेगा राइट वैल्यू ऑफ डब्ल्यू एन बी पहुंचने के लिए. बट अल्फा की वैल्यू अगर बहुत लार्ज होगी तो आप बहुत जल्दी पहुंच जाओगे. बट हो सकता है कि आप क्लोज टू जीरो जाने की जगह पे, बिकॉज क्या होगा, ऐसे जाएगा, राइट? तो आप क्लोज नहीं पहुंचे, बहुत दूरी थे, बट नेक्स्ट स्टेप में आप फिर से दूर हो गए, बिकॉज नाउ यू आर स्टार्टेड असेंडिंग इंस्टेड ऑफ डिसेंडिंग, राइट? So what is the right learning rate that you have to use? This is kind of an art. And
वही मतलब इसका भी कोई साइंस है क्या? मतलब ये लर्निंग रेट क्या होना चाहिए या अल्फा क्या लेना चाहिए, ऐसा कुछ होता है क्या?
तो इसमें मतलब दो तीन चीजें ही हैं क्राइटेरिया. एक तो होगा कि आपका गोल है मिनिमम पे पहुंचना, लोकल मिनिमम पे पहुंचना है यहाँ पे. तो आप जब आप छोटे छोटे स्टेप लोगे तो आपको टाइम ज्यादा लगेगा लोकल मिनिमम पे पहुंचने के लिए. इसका मतलब है कि आपको कंप्यूट ज्यादा लगेगा, आपको मॉडल को बहुत ज्यादा ट्रेन करना पड़ेगा, राइट, टू रीच द राइट वैल्यू. लेकिन अगर आपका
सिंपल ट्रेड ऑफ कॉल है वो, है ना?
हाँ, ट्रेड ऑफ कॉल है. अगर आप बड़े स्टेप लोगे तो फिर आप मिस कर जाओगे, राइट? किसी एक इटरेशन में आप जंप कर गए और नाउ द वैल्यू ऑफ डब्ल्यू एंड बी स्टार्ट बिकमिंग नॉन ऑप्टिमाइज्ड अगेन, राइट, फ्रॉम मोस्ट ऑप्टिमाइज्ड वैल्यू.
ठीक है,
मतलब इतना मुझे तय समझ में आया है. ये दो ट्रेड ऑफ्स है. ठीक है, तो वी विल मूव टू so this was about linear regression, and then how do you minimize the cost of linear regression. Now we'll go to classification. So classification again, we saw that there are two problems in supervised learning, right? One was predicting a number, and then other is basically classifying in the inputs into two buckets, right? Maybe that's images of a cat or a dog, or it's a tumor का size आपको दिया गया है, and then you have to predict whether that patient has cancer or not just based on the size of the tumor. So these are very different kind of problems, right? These are saying कि output क्या है. A है या B है output, right? So these are classification problems. These are also supervised learning problem. So classification problem थोड़ा सा different है linear regression use करने से, but again it builds on top of it. तो linear regression तो पूरा करेंगे ही करेंगे, but बाद में एक और function लगा देंगे to predict a probability, because what you are doing is you are just trying to predict a probability here of one output versus the other output. So linear regression is not the right algorithm for classification. I think इसमें भी there are theories to prove. I think we can easily understand. So what linear regression will do is, let's say it can find a value between, अगर मैं उसको scale कर दूं तो it can find a value between 0 and 1, right? So it could be 0.1, 0.2 or 0.19 or 5 or 0.57, something like that. But classification में what you want is you want to maybe say that 0.5 के ऊपर value है तो मेरा value output y हो जाए माना जाएगा, और 0.5 से कम है तो मेरा output मेरा y not माना जाएगा, right? So like that you want to do. So linear regression is not something you can apply to classification problem. That's what I'm trying to say. Because आप एक number, आप range के base में number नहीं predict कर रहे हो, आप probabilities को predict कर रहे हो. तो फिर हम आते हैं, so what is used here is basically logistic regression instead of linear regression. Logistic regression क्या है? Logistic regression is basically a simple sigmoid function, and इसको sigmoid function इसलिए बोलते हैं because उसका जो curve आता है जब हम plot करते हैं उसको, तो it's like a S-shaped curve. That's the reason it's called a sigmoid function. And so for example अगर हम वो वाला example लें tumor वाला, so what we will see is कि हम let's say हमारे पास ये training data points थे हमारे पास, right? ये जो आप देख रहे हो ऊपर x और नीचे x, तो ये हमारे training data points थे. इनको हमने जब plot किया तो what we saw is that there is a मतलब हम लोगों ने इसमें मतलब the output has been classified either as कि इस वाले आपको लेबल कैसा होगा उस वाले केस में, राइट? लेबल ऐसा होगा कि यार इसका ट्यूमर साइज है maybe I don't know 2 सेंटीमीटर या maybe 10 मिलीमीटर्स का, एंड देन 10 मिलीमीटर्स में आपका उसका ट्यूमर था, लेकिन maybe it was like 4 millimeter and then tumor was not there. So your output data will always be 0 and 1, right? Labels will always 0 and 1, and then you will plot it. So when you plot it, you will get a sigmoid kind of a graph. So what you do is आपने जो अभी linear regression किया था, you let's say your function was z, right? So you on top of z you apply one more function, right? And you pass it through one more sigmoid function, and the value is 1 by 1 plus e minus z. So e is the natural number, right? Which value is around 2.7, right? So what we do is हम लोग linear regression ही करते हैं, output को लेते हैं, and then we apply it to pass it through this function 1 by 1 plus e minus z, and then this value will always be between 0 and 1, and then we can easily say कि 0.5 के ऊपर है तो हम लोग उसको 1 मानेंगे, and then 0.5 से नीचे है तो हम उसे 0 मानेंगे. So this is logistic regression basically, right? So logistic regression में आप I think इसको एक बार देख लेते हैं just to get develop an intuition around this, कि अगर आपकी z की वैल्यू बहुत ज्यादा लार्ज होगी तो लॉजिस्टिक रिग्रेशन का आउटपुट जो होगा यानी 1 by 1 plus e minus z की आउटपुट हमेशा 1 होगी अगर you have a large value of z यानी लीनियर रिग्रेशन का आउटपुट अगर बहुत लार्ज आएगा तो योर वैल्यू विल बी 1, एंड इफ लीनियर रिग्रेशन का आउटपुट बहुत कम आएगा तो योर वैल्यू विल बी क्लोज टू 0. So this is your math about this, right? तो इसको sigmoid function कहते हैं, and this is the sigmoid function 1 by 1 plus e minus z. Its value will always be this between 0 and 1. So now let's go to so again some cases may the value is like this, where you have to predict, you have to find a, let's say you find a line, right? If you find a line which is let's say going like this, then your regression function that you have find out, that is able to fit to the entire training data, right? So it can say कि ये line है, इस line के ऊपर जो भी size होगा ट्यूमर का, maybe 0.2 mm के ऊपर जितना भी size है ट्यूमर का, वो I can always classify that as a cancerous, and then उससे नीचे जितना भी है I can always classify that as a non-cancerous. So you have to find a decision line somewhere, right? But let's say आपका again हम लेते हैं कि हमारा थोड़ा complex है, जो हमने linear regression का function decide किया, right? And that has more feature than just tumor size. Maybe there are more features to it. Then what happens is your data might look like this, right? So your X are all your those cases where tumor is there, and then these are the cases where tumor is not there, and then your decision line is like this, right? This line that you see. This is a decision line. So anything beyond this line, on top of this line is tumor, and then output is 1. Output should be 1 of logistic regression, and then below that line the output should be 0, saying that okay, no, it's not cancerous. So उस केस में आपका, so the idea is कि आपका जो curve आएगा, that could be of it may, you may not get a linear line in the output, you might get a very different kind of lines, right? जैसे आपको यहाँ पे दिख रहा है.
So Kunal, so can you just go to the function again? So this function like fx equal to wxt. So x can be your vector as well, and x can be your matrices as well, right? Matrix as well. So it's not just not like a simple yeah, like this here. It says as a vector, right? So I mean, it can be a vector, it can be scalar, it can be matrix, something like that, right?
X क्या हो सकता है, ये कह रहे हो क्या?
Yeah, no. So if you see here, right, z equal to wx plus b, right? So this is one function. So here, I was thinking that this is a one value, but it can be different value as well, actually, right? I mean, like it can be a matrix as well, it can be a vector as well. It will have a list of values, list of features, right? This like currently x is like one value. I'm just thinking one input value. But x, which is a vector, right? It will have a multiple multiple values.
वो तो अगर आप real world को model करने जा रहे हो, so it will not be a line, right? Because line is very simplistic. So it will most likely be a polynomial kind of like this, right?
No. What I'm saying is that like जैसे कि कोई भी जैसे कि हम ट्यूमर की बात करते हैं, तो ट्यूमर को डिटेक्ट करने के लिए जैसे कि उसमें मल्टीपल फीचर्स हो सकते हैं, राइट? मल्टीपल उसके इनपुट होते हैं. जैसे कि मतलब कोई ट्यूमर में किसी को पेन हो रहा है, साथ में बल्ज भी दिख रहा होगा, जैसे कि हर्निया है तो बल्ज दिखेगा, या तो फिर उसके बाद मतलब बहुत सारे पैरामीटर्स होते हैं. तो वो सारे पैरामीटर्स हम एक्स में पास कर देंगे, ऐसे एक्स में एज ए इनपुट पास करेंगे, नॉट द सिंपल वन इनपुट, राइट? That's what I'm trying to say.
I think Dheeraj, वही तो x1 x2 हुआ ना?
That's what I'm
This is the dimensionality of the data. This is we say multi-dimensional data. Okay.
So यहाँ पे जो जैसे मैं कह रहा हूँ, just size of tumor मैं कह रहा हूँ, तुम जैसे दूसरे फैक्टर्स बता रहे हो, राइट? तो वो दूसरे हो जाएंगे, राइट? So you can just, there would be a weight that you have to multiply it with, and then it will look like something like this, right? And maybe it's a linear relationship, or it's a quadratic relationship, or it's a cubic relationship, right? उसके बेसिस पे कोएफिशिएंट, उसके ऊपर स्क्वायर या क्यूब डाल दोगे, राइट?
Okay.
So ये सिंपल सा फंक्शन है जिसमें आपका w and b जो है वो पैरामीटर्स हैं, एंड w and b की वैल्यू को आपको प्रेडिक्ट करना है. x जो है वो डिफरेंट आपके इनपुट्स हैं, एंड देन आपको उसके बेसिस पे y को डिसाइड करना है.
और यहाँ पे इसका वैल्यू जो होगा z होगा, z को हमने सिग्मॉइड फंक्शन में पास कर देंगे, देन विल हैव अ क्लासिफिकेशन.
करेक्ट. हाँ, वो उतना ही है. सो इसकी ये जो fx और fwbx जो आएगा, दैट इज z, एंड z को फिर हम लोग ये कर, दिस इज अ सिग्मॉइड फंक्शन, यू पास इट थ्रू दिस फंक्शन, एंड देन यू गेट अ वैल्यू ऑफ gz, व्हिच इज योर आउटपुट ऑफ लॉजिस्टिक रिग्रेशन, राइट? उसके बाद फिर उसको आप 0 and 1 के बीच में, यू से कि 0.5 के ऊपर है तो 1, एंड ऐसे नीचे है तो 0, because you have to predict one class of it, right? उसके बाद इसमें मल्टी क्लासेस भी होते हैं, वो भी आएगा वाला बस.
ओके,
ठीक है, तो ये हो गया. I think this was just to show that, let's say if your function is like this, x1 square plus x2 square, something like ये है, तो you might get a square circle here, right? So this boundary here is like a circle. So anything within the circle is not a tumor. Anything outside the circle.
बेसिकली जो x होता है ना, वो दो तरीके का होता है. एक तो कैटेगोरिकल होता है और एक मतलब स्केलर होता है. मतलब स्केलर में जैसे हो गया कि जो प्रिडिक्टेबल नंबर्स होते हैं ना, जैसे फॉर एग्जांपल पेशेंट की एज क्या है, उसकी हाइट और वेट और बहुत सारी अलग अलग चीजें, और बाकी जो होता है वो कैटेगोरिकल होता है. जैसे कि फॉर एग्जांपल उसका ब्लड टाइप क्या है, जिसको हम लोग नंबर पे लिस्ट नहीं कर सकते. तो वो दोनों चीजें होती हैं, एक्स होती है. तो बाद में हम जो कैटेगोरिकल चीज होती है उसको हम लोग नंबर्स में लेके आने की ट्राई करते हैं, बेस्ड ऑन द लाइक जैसे हमारा जो इनपुट डेटा है. फॉर एग्जांपल अगर किसी का मान लो ब्लड शुगर ज्यादा है, तो उसको भी हम लोग 1 और 0 के बीच में नंबर में लेके आने की कोशिश करते हैं. मतलब तो उसके लिए हम लोग 1 हॉट एनकोडिंग और ये सब चीजें यूज करते हैं. और जो नंबर होता है वो तो ऑलरेडी नंबर में होता है. तो नंबर जैसे होता है उसको हम लोग फॉर एग्जांपल एज पेशेंट्स की एज है 20 से लेके 80 के बीच में, तो उसको भी हम लोग 0 to 1 के बीच में लेके आने की कोशिश करते हैं, बेस्ड ऑन उसका डिस्ट्रीब्यूशन स्टडी करते हैं, डिस्ट्रीब्यूशन टाइप कैसा है करके। तो वो डिस्ट्रीब्यूशन टाइप स्टडी करके हम लोग उसको मतलब हमारा गोल ये होता है कि कितने सारे कैटेगरीज है उन सबको देख के हम लोग को ये डिसाइड करना कि कौन कौन सी कैटेगरी है जो हमारे इनपुट में मतलब हमारे आउटपुट को डिसाइड करेगी, और बाकी जितनी एक्स्ट्रा कैटेगरीज है उसको हम लोग वहां से निकालते हैं, मतलब ताकि हम जितना कम मतलब डायमेंशनलिटी, जैसे फॉर एग्जांपल जितनी ज्यादा रखेंगे हम लोग उतना खराब होता है ना। इसका मतलब एक हमारे प्रोफेसर ने एक एग्जांपल दिया था मैच मेकिंग का, कि अगर कोई मैच मेकिंग के लिए जाता है तो अगर बहुत कम चीजें देखता है तो उसकी मैच मेकिंग के सक्सेस होने के ज्यादा चांसेस है, बट बहुत सारी चीजें अगर डिफरेंट डिफरेंट चीजें देखेगा, रेस देखेगा, एज देखेगा और बहुत सारी अलग अलग चीजें, तो उसका जो मैच मेकिंग होगी वो ऑलमोस्ट इम्पॉसिबल हो जाएगी। तो फिर वो एक हमारे प्रोफेसर ने इसका एक एग्जाम्पल दिया था। तो इसमें भी हम लोग मशीन लर्निंग में भी हम लोग यही चीज करते हैं कि हमारे मतलब अगर ट्यूमर प्रिडिक्शन करना है तो बहुत सारे मतलब कैटेगरीज होंगे मान लो, तो सबको मतलब नहीं देख सकते ना हम लोग, तो जितनी कैटेगरीज को हम लोग रिड्यूस कर सकते हैं उतना उसको हम लोग रिड्यूस करेंगे, और मतलब बाकी जितना एक्स्ट्रा चीजें होंगी उसको हम लोग निकाल देंगे, फिर उसको हम लोग एक्स में लेके आएंगे, फिर वो एक्स को की जो वैल्यू है वो मतलब 0.5 के ऊपर होगी तो हम लोग जैसे 1 में डाल देंगे लॉजिस्टिक उसमें, और अगर उसके नीचे होगी सिग्मॉइड फंक्शन में तो उसको 0 कर देंगे। तो बेसिकली ये होता है उसका।
हाँ, तो जितिन जो तू कह रहा है वो रेगुलराइजेशन होता है। रेगुलराइजेशन के अंडर में वो कवर करेंगे, मतलब इफ सो आइडिया जनरली जो आइडिया तुमने बोला कि अगर लेसर नंबर ऑफ फीचर्स हैं तो ओवरफिटिंग नहीं होगी और इट्स इजी टू प्रेडिक्ट, मतलब मॉडल जो होगा मतलब यू विल हैव अ गुड मॉडल, नॉट इजी टू प्रेडिक्ट। बट अगर मोर नंबर ऑफ फीचर्स हैं तो मे बी यू विल हैव ओवरफिटिंग एंड यू डोंट हैव अ गुड मॉडल, राइट। बट बहुत टाइम पे आई थिंक दैट इज नॉट अ स्कोप, राइट। मे बी यू हैव टू केटर टू ऑल द फीचर्स। तो उस केस में व्हाट आर द अदर वेज टू रेगुलराइज, राइट, वो देखेंगे। ठीक है, बिफोर वी प्रोसीड एनी क्वेश्चंस है या कमेंट्स या कोई गैप? ओके सर, ठीक है, तो आगे बढ़ते हैं। तो नाउ वी विल सो आई थिंक कॉस्ट फंक्शन के बारे में समथिंग व्हिच आई हैव रिटन इज why do we need a cost function? So learning requires a scalar signal that tells us how bad our predictions are, right? So basically हमने जो 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 हमने डिसाइड किया है फंक्शन, is it a good or is it a bad? How do we know? A cost function tells you that, right? So cost function is kind of a, it's like a scalar output. You get some number saying that okay, no, your cost function, your model is correct or your model is bad, right? So it's like a matrix which you can use. और हम लोग यही यूज क्यों करते हैं, राइट? ऑफ कोर्स यू कैन डू डिफरेंट काइंड ऑफ कॉस्ट फंक्शन। तो इसका आइडिया ये होता है कि अगर आपकी आपकी बड़ी वैल्यू है, बड़ा डेविएशन है ट्रेनिंग डेटा के साथ, तो वो आपको, अगर आप स्क्वायर ले रहे हो, राइट, मीन स्क्वायर एरर ले रहे हो, मीन स्क्वायर ले रहे हो, तो आपको ज्यादा पेनलाइज कर रहा है बिकॉज आप स्क्वायर ले रहे हो उसका। और अगर स्मॉलर है तो आपको पेनलाइज कम करोगे, राइट? तो वो दिस इज व्हाट वी वांटेड एक्चुअली, कि अगर स्मॉल है तो वी आर स्टिल ओके विद दैट, बट इफ द डेविएशन इज लार्ज we wanted to penalize more. So maybe that's the reason mean square error makes sense more. And I think square से वो भी idea होता है कि let's say you are on a higher side or a lower side, it's still you get one value, right? So you basically square it. And then mean is done basically to bring it and to do a feature scaling and then bring it to a certain range, right? Because you don't want output कोई बड़ा number या छोटा number वैसा नहीं चाहिए होता है. You want it to in certain range because you have to compare across different values itself. That's the reason you always mean it, take an average of it, so that you keep it in under certain range. So this is ये decide होता है, I think kind of ये mean square वाला जो है the cost function is decided. We've already looked at, just to refresh, we've already looked at the cost function. So this is the cost function here. What we do is 1 by m, and then we do a summation of error across all, and then we do a square of this.
So basically instead of having simple difference, हम उसको square भी करते हैं, so that कि अगर error बड़ी है, for example 4 है, तो square होके 16 हो जाएगी, तो इसको in that way we are penalizing it. छोटी mistake को बड़ी mistake बना रहे हैं, ठीक है? और अगर कम error है 0.04 है, अगर मैं उसको square करता हूँ तो वो छोटी error हो जाएगी, तो we are ignoring it in that way. We are not penalizing the square. That's what it gives to me.
Yeah. ठीक है, तो So cost functions are the objective. So there's a primary objective of learning, cost function, and that is, it bridges the gap between prediction and optimization, right? So आप predict कर रहे हो, but how closely are you to the right value? So it's like an optimization function. ठीक है, अब देखते हैं cost function for the हमने logistic regression के लिए हमने देखा था. This is the cost function for the logistic regression, right? Sorry, ये वाला.
लीनियर के लिए हमने देखा था.
हाँ, लीनियर के लिए देखा था, सॉरी. अब हम लॉजिस्टिक्स के लिए देखते हैं कि व्हाट इज द कॉस्ट फंक्शन फॉर लॉजिस्टिक रिग्रेशन. हाँ, तो सो पहला लेट्स एस्टैब्लिश दैट वी कैन वी यूज द सेम कॉस्ट फंक्शन और डू वी नीड अ डिफरेंट कॉस्ट फंक्शन. सो एज इट कैन बी सीन द कॉस्ट फंक्शन फॉर लीनियर रिग्रेशन डज नॉट कन्वर्ज फॉर लॉजिस्टिक रिग्रेशन. सो लेट्स से आपने क्या किया कि आपने अब आपके पास क्या है, उसका आउटपुट है या तो 0 है या 1 है क्लासिफिकेशन प्रॉब्लम्स का, राइट? So if you are doing that, what you are seeing is कि आपका जो लीनियर रिग्रेशन के केस में ये इजीली कन्वर्ज हो रहा था, राइट? बिकॉज यू आर ऑलवेज गेटिंग कि एक पॉइंट पे मिनिमा मिल रहा है आपको, उसके बाद वैल्यू बढ़ जाएगी, राइट? तो दैट कन्वर्जेंस वाज हैपनिंग यूजिंग दिस स्क्वायर मीन स्क्वायर एरर का जो हमने कॉस्ट फंक्शन यूज किया था. बट सेम अगर आप लॉजिस्टिक रिग्रेशन में अप्लाई करोगे तो आपको ग्राफ कुछ इस तरह का दिखता है, राइट? So what you will see is there are a lot of minimas, right? And then maybe the real value is this one that you want, but आप proceed ही नहीं कर पाओगे because you're based on your learning rate you arrive at this place and then you decide, yeah, no, this is not the right optimization, right? So you will not be able to use the mean square जो ऊपर हमने use किया linear regression के लिए as a cost function, and you'll have to arrive at a different cost function. So अब हम देखते हैं कि what kind of cost function is required. So the cost function for logistic regression is this, right? So again ये loss function लिख रहे हैं. Loss function and cost function में difference ये होता है कि loss function is across one data set and cost function is summation across the entire data set, right? So अभी हम पहले loss function देखते हैं and then we will arrive at cost function. So loss function is L of f of, so this is your output and then this is your label, राइट? एंड देन व्हाट यू डू इज अगर उसकी वैल्यू 1 है तो आप लेते हो माइनस लॉग ऑफ एफ ऑफ एक्स आई, एंड देन अगर उसकी वैल्यू 0 है तो आप लेते हो माइनस लॉग ऑफ 1 माइनस एफ एक्स. सो ये आपका लॉस फंक्शन होता है फॉर ग्रेडियंट फॉर योर लॉजिस्टिक रिग्रेशन. एंड अब इसको आप वो करते हो, इसको आप प्लॉट करोगे तो यू गेट अ ग्राफ लाइक दिस, राइट? So loss is lowest when W predicts value close to true and label Y. So इस केस में आपका loss lowest कब है? जब आपकी जो value आती है वो true के आसपास आती है, right? This is what it's trying to say. So आपका जो loss function है, logistic loss function है, this is how it will look like. अभी इसको we can unify this and then we can make an equation. These are the two classes of it. So आपका logistic loss function is okay. I think वो मैंने लिखा नहीं है इसमें कि what is, how do we, so this you can just do a summation here with minus log of this and then you can, I think plus या minus होता है बीच में, and then you add this value, then this becomes your loss function across this value and then you can do a summation भी. I think maybe I'll share it separately. ये लिखा है क्या? हाँ, यहाँ लिखा है. No, ये तो linear regression वाला ही है. So that brings a loss function for this. So idea is कि there is a different loss function or cost function which looks like this instead of the mean square function that we do. Because यहाँ पे हमारे पास output 0 1 ही होता है तो we take a log of this. So अगर आपकी value 1 से ऊपर है तो आप minus log of fx use करते हो, अगर 0 है तो आप ये use करते हो on the loss function. Now there are 3 kinds of, again moving ahead, यहाँ पे अगर कोई question है तो pause. ठीक है. So now there are 3 kinds of basically जो आपने model decide किया, there could be 3 ways in which model can differ with the actual output. So it could be an overfitting model, right? Or it could be a underfitting model, or it's a good model. And what do we mean by good model is that it generalizes across the training data and also the real world data. That's a good model. So the generalization is where we want to be. बट ये दोनों केसेस होते हैं, ये दोनों केसेस होंगे तो क्या 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 प्रॉब्लम है एंड हाउ डू वी सॉल्व फॉर दोज प्रॉब्लम्स. अगेन दैट इज लुक्ड एट एकेडमिकली. सो ओवरफिटिंग होता है, इसका मतलब है कि आपका जो जो डेटा है वो, आपका जो मॉडल है वो ट्रेनिंग डेटा से तो इस बहुत अच्छा फिट हो रहा है, राइट. इज फिटिंग वेरी वेल, इनफैक्ट इज फिटिंग टू वेल फॉर द ट्रेनिंग डेटा, right. And then so in that case what you say is there is a very high variance, so it fits very well with the training data. But agar aap real world data leke आओगे which is out, not in covered in the training data, then you will see that for those data it's not doing good. So this is an overfitting and high variance case. Underfitting वाले केस में क्या होगा कि आपका डेटा जो है वो मॉडल जो जो आपने ट्रेनिंग डेटा दिया है उसको ही फिट नहीं कर पा रहा है, राइट. So this is a case of very high bias. I think let's look at that. So how do we solve for, let's say, overfitting, right? Overfitting is that it solves well for the training data, but it does not solve well for the real world data. So in this case, maybe you can do, Jitin was discussing this, right? So you can say, maybe I don't have sufficient training data, right? And then you will say, let me collect more training data. Or you will say that this is the point which he was mentioning, that I can exclude certain features, because by bringing lot of more features, my model is becoming very complex, and then to make the training data fit, my model is becoming very complex. So मेरा कर्व जो है बहुत ज़्यादा ऐसे जैसे ऊपर नीचे से हो रहा है, let's say when you plot it, but it's not then able to cater to the real world data, right? So then you will say, okay, let me clean up some features which are, let's say, not important features. I'll just only keep maybe high 3 features, and then then maybe it generalizes well with the training data and also with the real world data, right? Or third way is to use a generalization parameter. So generalization parameter क्या करता है कि this again you can it allows you to learn and it allows you to this, and by reducing the weight across all the जो आपने आपके जो features हैं अभी, जैसे you want to focus on 10 features or 1 feature or 100 features, it will reduce the weight of those features, right, by adding another parameter called lambda. And then उसके कारण से वो lambda, because you are adding it, the weight across the current features will reduce a lot. एक मिनट, अजीत कॉल कर रहा है. हाँ जीत. हाँ एक सेकंड भाई, लिंक को ही पिंग कर देगा क्या व्हाट्सएप ग्रुप में? अजीत को लिंक पिंग कर दो धीरज.
ओके ठीक है, मैं कर दे रहा हूँ.
ठीक है, तो रेगुलेशन में व्हाट वी डू इज वी ऐड वन वेरिएबल कॉल्ड लैम्डा, and then that, because of that variable, the weights of the features will get reduced or rather get optimized, and because of that it will cater, again it will become generalized and it will cater both to the training data and the real world data. So regulation का आप ये आपने already देखा, this cost function was already there, and then what lambda is called here as a regularization parameter, and then this is what we have added. So across all the value of w's, what we do is we do a summation, we multiply by a factor of lambda, and we also do it for b, but b के लिए this is kind of optional, sometimes it's done, sometimes it's not done, but w is, because b is anyway scalar, w is the weight which goes and multiplies all the features. So this is extra parameter, this is called as regularization term, and then this helps optimize the value across all the features. So regularization को देखते हैं. So what happens is now, so this is mean squared error regularization term, data balances both goal, keeps w small. So let's say you had this value, and then what happens is fx equal to b, whose keep w very small. So I think this same thing is being explained, that अगर आपने lambda को let's say आपने lambda की value जो है बहुत बड़ी ले ली, right, what will happen? if you take a high value of lambda, then your weights will become very small, right? And this we can, there is nothing fancy here, we can just understand based on this equation, because आप एक high value का weight लोगे यहाँ पे, and then you are multiplying that across all the weights, and overall goal is to basically minimize and make this close to zero. So what will happen is यहाँ जो W की value होगी वो कम हो जाएगी, right? And if you take a small value of lambda, then it will not affect that much to the value of W. But so this is how you decide the value. So you add a regularization parameter, and then you try to balance so that you can reduce overfitting and make it closer to this one. Make it generalized, right? This is regularization. ठीक है, so I can now and I will change.
सिंपल हम क्या बोलेंगे, रेगुलराइजेशन मतलब क्या करना चाह रहे हैं हम लोग, वेट एडजस्ट करना चाह रहे हैं।
सर रेगुलेशन so मतलब आपका ओवरफिटिंग की प्रॉब्लम होती है मॉडल जो आपने डिसाइड किया, राइट? सो ओवरफिटिंग का मतलब है कि आपने जो ट्रेनिंग डेटा था उसके लिए तो बहुत अच्छा काम कर रहा है, राइट? मतलब इट्स लाइक, अगर मैं एक बार ये वाले एग्जांपल पे जाता हूँ, लीनियर रिग्रेशन वाले पे, सॉरी, हाँ, तो इस वाले में आपका कर्व कैसे जाएगा, ये एक लाइन यहाँ से निकलेगी, फिर वो एक्स को टच करेगी, फिर यहाँ नीचे आएगी, फिर इसको ऐसे ऐसे कर्व करके, तो जितना ट्रेनिंग डेटा होगा ऊपर नीचे करके सबको कवर कर लेगा, राइट? तो आपका ट्रेनिंग डेटा तो सुपरली वेल फिट हो गया, मे बी आपका कॉस्ट फंक्शन इज नाउ क्लोज टू जीरो। लेकिन अगर आप, क्योंकि ये बहुत ज्यादा कर्वी हो गया और जस्ट टू मच, इसका बहुत ज्यादा ओवर फोकस हो गया ऑन द ट्रेनिंग डेटा, आप अगर रियल वर्ल्ड डेटा के लिए प्रेडिक्ट करने की कोशिश करोगे तो इट विल नॉट डू, बिकॉज देयर इज नो कॉमन ट्रेंड और कॉमन दिस दैट इट्स ट्राइंग टू एबल टू फिट। सो उस केस में that's a problem, right? Because our goal is to basically predict for the new data, right? Then so then the idea is ki usme what has happened is, now this is not helpful to us. What we want to do is we want to reduce the weight and then maybe generalize it. So maybe jo aapne training data calculate kiya hai usme maybe there is some problem, right? And then maybe some training data is generally maybe not fitting the trend as well, right? ऐसा भी हो सकता है कि आपने ट्रेनिंग डेटा कैलकुलेट किया बट वो ट्रेंड जो होगा उसको नहीं कैप्चर कर रहा होगा, ये भी पॉसिबल है। तो उसमें आपका आइडिया ये है कि मेरा एक ऐसा मॉडल बने बाय लुकिंग एट जनरल पैटर्न अमंग द ट्रेनिंग डेटा सो दैट इट फिट्स द रियल वर्ल्ड मोर। सो आप क्या करते हो, रेगुलराइजेशन पैरामीटर लैम्डा ऐड कर लेते हो, which is lambda 1 to m, and then you take you square all the weights and then you try to average it out, so that आपका जो आपने वेटेज जो दिया है सारे फीचर्स को वो फैक्टर इन कर लेगा, उसको रिड्यूस कर देगा, and then you are able to make a general pattern, and then that caters to the future data also. So ये फंडा है रेगुलेशन का। So there are three ways to solve for overfitting. One is maybe collect more data, maybe include or exclude some features. So for example आप square feet भी ले रहे हो, number of bathrooms वगैरह भी ले रहे हो, location ले रहे हो, maybe कलर, पेंटिंग, बिल्डर, क्वालिटी, ये सब ले रहे हो अगर हाउस को प्रेडिक्ट करने के लिए, बट आपने इतने ज्यादा फैक्टर्स लगा दिए कि आपको अब रियल प्रेडिक्शन करने जा रहे हो तो नॉट एबल टू डू करेक्टली। तो यू विल से कि मे बी some of the things are not important and let me just take square feet, area, year, या फिर कितना ओल्ड है हाउस, ये सब मैं ले लेता हूँ, and those are more important and then that can predict the data bit. This include and exclude certain features. In the regulation we already discussed. ठीक है, I think 1 hour हो गया है. I'll just go to the neural network and how we will build on top of it. अगर इसमें कोई, so mathematical background इतना ही था. So this is the core and most fundamental mathematical background which is used, and यही background सभी में use होता है. अब न्यूरल नेटवर्क के लिए भी यूज होता है, उसके लिए भी यूज होता है, एटलीस्ट जो बेसिक मैथ्स है. उसके बाद बहुत सारे अलग अलग एल्गोरिथम्स हैं जो build which are built on top of it. ठीक है, so I'll go to neurons now. So now थोड़ा सा theoretical है फिर से ये. So अभी again न्यूरॉन का भी जो बेसिस है या इंस्पिरेशन है, again it was the neuron in the brain, human brain. So what happens inside a neuron is that आपका न्यूरॉन का इस तरह का स्ट्रक्चर होता है, एंड एक आपका ये न्यूरॉन है. सो इस न्यूरॉन में कुछ इनपुट्स आते हैं, inputs which could be from other neurons, and then it will do some processing and then it will give an output. So कोई electrical signal आता है, it does some processing, activation, and then it gives an output to another neuron. Again, that neuron may get inputs from a lot of other places, it will do some processing and then it will give an output to some other. So this is fundamentally what happens inside the human brain. मतलब ऐसा नहीं कि इतना ही होता है, बट एक इंस्पिरेशन लेने की कोशिश है यहाँ से. एंड व्हाट इज सेड इज कि यहाँ पे जो डिफरेंट डिफरेंट न्यूरॉन्स हैं, उनको कितना काम करना है, क्या काम करना है, ये कैसे लर्न किया होगा, ये सराउंडिंग्स को देख के न्यूरॉन्स ने लर्न किया है. एंड दैट्स हाउ दे डू प्रोसेसिंग. सो एक पर्टिकुलर एक्शन या एक पर्टिकुलर इनपुट को प्रोसेस करने के लिए देयर कुड बी अगेन थाउजेंड्स ऑफ न्यूरॉन्स which could be involved, which can pass and the electrical signals, and what should be the amount of that signal which is passed is done based on the computation which happens inside the neuron. So this is the inspiration, and based on that the neural networks were initially conceptualized, and again it was conceptualized way back before that AI wave. But the theory was there, but it was not able to come at the current scale, right? What happened in 2022 after ChatGPT launch, and we will look at why it has happened, right? So what happened is why neural network took off. So this is a fundamental question, that since this theory and this basis was available since 1950s, right? Machine learning का तो पहला जो algorithm था 1950s में machine learning का, that came I think in 1959, and then it came from this person. This was Arthur Samuel in 1959, and who used temporal difference learning to basically एक checker का game होता है, and he used this temporal difference learning to basically make the machine learn the checker game and play the checker game, and then it was able to slowly even beat him and then beat the experts in that game, right? So the idea is that this idea about existed from very long time, but it was able to do these kind of things, ki small game ko khelna ya ye sab karna, but it ideally didn't really took off. Why did it took off now, right? Or maybe in last decade. So it took off because of this thing, right? That the amount of data, so which became available because of the big data in the last 5 to 10 years, has basically made the current revolution in the AI space possible. So what researchers have seen is कि आपके पास अगर small amount of neural data है, तो आपका performance भी उतना ही रहता है. अगर small data है तो वो performance कम रहता है. As and when the amount of data that you have increases, your performance also increases based on that. So जो अभी large neural networks which became possible, and then they were able to give you the best performance that we are seeing right now. It's because of the big data which has been possible in the last few years, because there are now so much amount of data which is available on internet. Fundamentally the neurons on the neural network has not changed. It's just those same neural networks, but because of the amount of data, we are able to train those neural networks, and then the weights that they keep across all in different features, that they can adapt so well, and that they are able to now predict the next words in case of LLM or different use cases that we have found. It's only been made possible by the huge amount of data which is available in that field. So if large neural networks are trained with huge amount of data, many applications became possible, like speech. So this was seen a little before the LLM wave, that speech recognition, translation, all these things could be solved, because a lot of this translation ka you can do. The data was traditionally also available, maybe without internet also, right? So you can encode the books and all, and then these things were solved. But largely LLM wale problem got solved because of the internet and the huge amount of data which became available to. So what is a neural network, right? So neural network is basically a logistic regression stacked multiple times. So ये देखते हैं, right? What is so logistic regression we have learned, and then it says that, let's say you stack logistic regression lot of times, right? Then that essentially makes a neural network. We will look into that. एक बार what we can do is, this is the example. So let's say we want to do a demand prediction, and these are the inputs. So price is let's say this demand prediction we want to do for a cloth, right, or an apparel piece, and then we want to say whether that particular, based on these inputs, whether the seller of that apparel is a top seller or not. So what are the input parameters? Let's say the price of the apparel, shipping cost, marketing, and material. These are the shipping costs. These are the different inputs. And now you want to predict whether he's a top seller or not. So based on these things, what we can say is, हम लोग इनके parameter के basis पे we arrive at certain other parameters, which we say is affordability. So we say that being a top seller is a function of affordability, awareness, and then perceived quality, perceived in the minds of consumers. So whether it's affordable, whether there is sufficient awareness among different consumers, and whether quality-wise, how do they perceive, whether they perceive this to be a good quality or a bad quality. Based on all these parameters, you will classify them as a top seller. So the idea is that you take all these things, then you pass on to one layer of neural network, and then after that, you compute, let's say, affordability. So affordability may be the function of price and shipping cost. अगर lower है price, shipping cost lower है, तो it's more affordable. Marketing आपने कितनी की है, branding उसका, so that decides how much consumers might be aware of it. And then materials, what is the quality, right? So what is the material with which it is built? So that may decide the quality of it. So you decide, so by combining all these things, and then maybe quality also decides based on price. So maybe you say it's a higher price, so maybe it might be of a good quality. So you take all these things, and then you create again a layer of neural networks, and then you again combine all those things, give certain weight to that, and then you decide an output between 0 and 1, or maybe a linear scale between 0 and 1, saying that अगर वो you can scale that 0.9 है तो is a very top seller, 0.7 है, 0.6 है तो average seller, and 0.1 है तो is a poor seller. So that kind of scaling is a very simple problem, right? But basically a combination of steps. So now what you can do is you can combine all of these things into different kinds of layers. I'm just trying to come up with why the network is required to solve this, right? Why it's not a simple logistic regression or a linear regression problem. That's what I'm trying to model using little complex problem, right? So now तो आपने क्या किया कि पहला लेयर आपने ये सारी चीजें डाल दी पहले लेयर में, उसके बाद आपने सेकेंड लेयर लिया, सेकेंड लेयर में आपने ये सारी अफोर्डेबिलिटी, अवेयरनेस एंड परसीव्ड क्वालिटी. सो देयर इज वन मोर लेयर दैट यू हैव एडेड, एंड देन you add a weight. You think that maybe affordability is of certain weight. So what you will do is you will assign again a W1, W2, W3 across these. So first इस layer पे W1, W2, W3, W4 होगा, इस layer पे फिर W1, W2, W3 होगा, and then there is an output layer. So you do a math, you find out this, and then you find out this. So now you know what is the output. Based on that you can classify. So what you are seeing is each of these one circle that you are seeing is basically doing one logistic regression, right? Or linear regression. So what it's doing is it's taking the value and then trying to find out a function and then multiply by that with weight and then find out a value out of it, and that value goes to the next layer, right? So this is what is happening in each layer. So each of them is a neuron, because one logistic regression is one neuron, and then this is one layer of, this is called as one layer. So it could be layer 1, layer 2, layer 3, layer 4, layer 5, and then finally the output layer of that. So जब आप layers को count करते हो तो input layer is not counted. ये बीच के layers आ रहे हैं, and output layer is counted in the number of layers in the neural network. And then you say that this is the n-layered neural network. All the layers which are before the output layer and not the input layer, those are called as hidden layers in that neural network, because these are generally not seen from the outside. And then you compute the value of, and so this is how it is. And then you arrive, the final layer will have only one neuron, which basically says what is now the range of the output. So this is how you decide it. अब इसमें थोड़ा सा let's develop some intuition by going through a face recognition problem, that what might be happening in different layers that you decide, right?
Okay, so Kunal, so this hidden layer, I mean, the ML engineer will decide, create that, or this is automatically created when we do the learning, training.
So what you're asking is what is the architecture of that neural network, right? So architecture of the neural network is decided by you only. Let's say you want to train the model, right?
Yeah.
So आपको कितना complex रखना है अपना वो,
Yeah.
right? That you will decide. And then you will start training it. So based on training, what will happen is कि weight assigning will keep on varying, right? कितना training करते हो आप,
Got
किस
it.
quality का data है उसके वजह से. But architecture, मतलब it will be, let's say, 1,000 layer neural network, and each layer will have, let's say, hundreds or thousands of neuron. That is completely decided by you, right? The only idea is the more complex your neural network is, the it will be maybe better able to model the real world, because वो weights को उतने ही, मतलब just intuitively सोच के देखो कि it will be able to adjust and adapt to different kind of data points, and then वो जो weight assign करेगा across each neuron and then each layer, वो उतना ही adaptable होगा. वही idea है. So architecture पूरा you decide based on how much the amount of resource or compute वगैरह वगैरह finance that you have, right? And what kind of, but and that much close you might be with the real world. ठीक है. So now let's go to the intuition of neural network. So इसमें intuition देखते हैं, right? So what happens maybe in the initial few layers, क्या होगा बाद में क्या होगा, right? So this is, let's say, one image given to a neural network, and as a face recognition problem है ये. तो इसमें क्या होगा कि आप देखोगे कि जो पहला जो लेयर है ना, उसमें it will just try to find out simple lines and all, right? So जैसे इसमें this is the first neuron का what is happening inside that. So it's trying to say कि यार जैसे ये एक small edge इसने decide किया इस वाले में, right? अगले वाले में क्या हो रहा है कि थोड़ा सा वो evolve हो गया, and then it's able to decide the features of the face कि कौन सा eye है, कौन सा nose है, क्या hair है, right? ये सारी चीजें it's able to decide. And then on the subsequent layers, on a higher layer, right, which is more closer to the output side, you are able to see that it's able to kind of recognize the whole face of it. So this is what is happening inside various layers of the neural networks. So this is kind of giving an idea. ये starting वाले जो आपने यहाँ पे जो weights और ये दिए हैं, वो एक small काम कर रहा है, is very very localized. ये एक पर्टिकुलर फीचर ले रहा है फेस का, एंड देन उस पे काम कर रहा है. और जो जो एडवांस लेयर्स हैं, सब्सिक्वेंट लेयर्स हैं, दोज आर डूइंग मोर मे बी ग्लोबलाइज्ड वर्क और मे बी लार्जर. इसका इंस्टेड ऑफ रीजनल, yeah, it's doing a little larger. So यहाँ पे it's able to even find की what is the now features of the face. The full face now it's able to compare. So this is very good. I mean, very good slide. Give an idea of develop an intuition that what happens in the initial layers, and this you can apply to other cases also. कोई भी फेस रिकॉग्निशन या कुछ भी क्लासिफिकेशन, जैसे मैं कार का इमेज डाल दूं यहाँ पे, राइट? सो कार के इमेज में क्या होगा कि स्टार्टिंग में वो सिर्फ वो देखेगा कि कहाँ कहाँ स्ट्रेट लाइंस है, कहाँ पे दूसरे तरह के लाइंस हैं, ये सब डिसाइड करेगा. मे बी सेकेंड वाले में वो डिसाइड कर पाएगा कि ये इसका विंड स्क्रीन है, ये ग्लास है, ये बम्पर है, ये हेडलाइट है. एंड देन सब लास्ट वाले के आसपास इट विल डिसाइड द होल कार. इट विल एबल टू maybe find what kind of car it is, right, in the subsequent layers. So this gives an intuition ki kya hota hai different layers. So ab neural network mein there is something called as an activation function. Activation function kya hota hai? So activation function, again, what we have learned earlier is basically fx, right? So fx is an activation function here. Activation function जो नाम है वो is again brought from, is like an brought from inspiration from biology itself, कि आपका जो न्यूरॉन है उस न्यूरॉन को आगे एक्टिवेशन भेजना है कि नहीं भेजना है, और किस अमाउंट का एक्टिवेशन भेजना है. मे बी हाई वोल्टेज सिग्नल भेजना है या लो वोल्टेज सिग्नल भेजना है, राइट? So that is decided. That's an activation function, whether the neuron will activate the subsequent neuron or downstream neuron or not. So it's the same idea. And this is basically fx in our functions. Linear regression and logistic regression में जो fx की value है, that is the activation function. So activation function is a mathematical component in neural network that decides whether a neuron should fire, be activated by transforming the weighted sum of its input, introducing crucial non-linearity. राइट? बिकॉज मान लो कि आप एक्टिवेट नहीं कर रहे हो, आगे नहीं कर रहे हो, तो इसका मतलब है कि आप सिग्नल को प्रोपेगेट ही नहीं कर रहे हो. तो मे बी व्हाट विल हैपन इज इट्स नॉट इवन चेंजिंग द वैल्यूज. सो इफ यू आर प्रोसेसिंग इट अक्रॉस लेट्स से a layer of neural network, nothing is happening. The same value is getting propagated across all. But if there is an activation function and then it's working, what it's doing is now it's trying to change the values, and based on the change values, different parameters across different neurons will adapt, right? So this is a very important thing. So, so introducing crucial non-linearity, which allows the network to learn complex patterns beyond simple linear relationships, much like biological neuron deciding to fire. So adaptation. So without them, even deep network would behave like a linear model, unable to solve complex tasks like image recognition or language translation, right? So I think ये समझने की जरूरत है, already discussed. Now, what are the activation function के बारे में? So the key importance is again non-linearity. It helps you make decisions, and then gradient calculation. Gradient calculation कैसे होता है? Because you are able to. So gradient calculation back propagation में होगा. We can look at it little later. Because what you are right now you are doing, this is forward propagation, right? This is a forward propagation example. So you are kind of you have given an image, and then you are asking it to recognize or identify who is the person here. So you're trying to pass it through various layers. So this is going left to right. So that's the reason it's called forward propagation. And then it's trying to identify. But during that, let's say a training stage, you go backward, and then you try to give labels, and then you, based on that label, at every layer it will try to compute how much it deviates from the real from the actual value, right? And then based on that it will adapt. Different neurons will adapt their parameters when you try to train the data. So training will be a backward propagation. Okay, how it's simplified, I think input is of the we have seen only. Sigmoid. These are different kinds of examples. So sigmoid function, ye tan h hai. These are different kinds of. This is, I think, used. This we can talk about. Highly used. So rectified linear unit. So what this does is, this is basically a simple, again, a simple equation. अगर ये कहीं है तो मैं दिखा देता हूँ इसका. This just takes a max of that. So it will, अगर value 0 से कम है तो ये 0 देगा. Negative value है तो 0 देगा. और negative value नहीं है तो ये वो value दे देता है. This is the ReLU function. So it does not pass on the negative values. That's the idea. So outputs the input if positive and 0 otherwise. Yeah. Sigmoid we have already looked at above. 1 minus E minus G. 10H back propagation. So back propagation is efficiently computes gradient for all parameters using chain rule. So back propagation is what you do during a training time, and then you give an actual level, and then you say that, okay, at an output level, what was the, let's say, difference from the real world, and then that difference it will try to incorporate into that variable. The same हम लोग cost function को use करके कर रहे थे, right? And then this will pass on that diff to the previous layer. Previous layers will adapt, and then this goes on like that. So this is what happens during back propagation. So efficiently compute gradients for all parameters using chain rule. This enables training deep networks, scaling to millions and millions of parameters. Yeah. I think this is all in the foundation I had on theory for this week. उसके बाद कुछ questions हैं which I had and I have listed down. We can go over it, or we can go over it later, but just wanted to pause here. But this is the fundamentals. Yeah.
Nice, Kunal. That was good. तुम ये डॉक्यूमेंट भी शेयर करोगे? ये वाला?
हाँ, शेयर कर दूंगा. तो उसमें क्या है? ये अपने ग्रुप में डाल देते हैं अपने वाले में. I'll put it here. Yeah. So we can discuss it. What are the thoughts on this? We can maybe. So some questions I had just listed down, which helps basically understand it or connect करने में, intuition में, because ये fundamentals को connect करना to what we hear and see in the ML world, that is also important. Yeah. थोड़ा सा डिस्कस कर लेते हैं, I think, before we proceed.
हमने ट्रांसफॉर्मर डिस्कस नहीं किया ना अभी, मतलब like this is regarding the question कि why transformers speed-based CNNs and RNNs.
I think वो क्वेश्चन, हाँ, वो क्वेश्चन में कहीं है. तो आई जस्ट ट्राई टू कवर, बट ट्रांसफॉर्मर्स नहीं कवर किया हमने।
Right, मतलब तब it will be more understood, right? Like
हाँ
there are different statements.
ठीक है, एनी कमेंट्स बाकी लोग? अंकित सर, ब्रजेश?
काफी सही था,
बढ़िया था।
बढ़िया।
थोड़ा सा ट्रांसफॉर्म डिस्कस किया है ना, RNN और
डिफरेंट टाइप ऑफ न्यूरल नेटवर्क कह रहे हो ना, वो सब? हाँ, वो कवर कर लेते हैं वीक उसमें, नेक्स्ट वीक में।
नेक्स्ट वीक में है हमारे CNN वगैरह RNN कवर करना है नेक्स्ट वीक में, देख सकते हैं एक बार क्या है।
हाँ, मतलब जो भी इसके बाद जो बच गया ना, वो नेक्स्ट वीक में कवर कर लेते हैं। बिफोर वी गो टू लाइक ऑल दिस, एक वीक और है हमारे पास, उसमें विल टेक केयर। वो सब ऐसे ट्रांसफॉर्मर और वगैरह, दिस डिटेल नेक्स्ट वीक यू विल टेक, राइट? सो यू विल कवर ऑल दिस थिंग्स ना।
यार देखता हूँ, मेरे को पूरा पढ़ना पड़ेगा भाई। मैं बताता हूँ
तो बता दे, नहीं करेगा तो फिर वी विल डिसाइड, राइट, हु डज इट, बिकॉज़ वी हैव टू डिसाइड इट।
ठीक है, तू ही कर ले यार फिर कुणाल, अगर कर सकता है तो। ये तो मतलब मैं 2-3 दिन में अपडेट देता हूँ, क्योंकि ना यार मैं थोड़ा मतलब इंटरव्यू स्पेसिफिक होकर भी पढ़ रहा था, तो मेरे को पूरा ये चेंज करना पड़ेगा अपना शेड्यूल।
ठीक है, मैं कर लूंगा। ठीक है, तो ठीक है, आई थिंक वी कैन गो ओवर द क्वेश्चंस, अगर कोई देयर आर नो कमेंट्स और डिस्कशंस। व्हाट वी कैन डू, या
तो डिस्टर्बेंस आ रहा है।
ओके सर, कुछ आवाज आ रही है आपकी साइड से?
अरे सॉरी, मैं घर वाले बोल रहा था।
तो सो वी कैन गो थ्रू ओवर दिस। आई थिंक एक और सेशन का टाइम 4:30 तक ही था, तो जस्ट सेइंग कि अगर वी कैन टेक अ क्विक क्विज जो हमने लास्ट टाइम किया था, उसके ऑन द कॉन्सेप्ट दैट वी हैव, एंड विल गो राउंड रॉबिन एंड ऑप्शनल जो लोग करना चाहते हैं, तो दैट हेल्प्स बेसिकली सी दैट हाउ मच वी हैव अंडरस्टूड। एंड
रिकॉर्डिंग क्लोज कर दूं मैं भी रिकॉर्डिंग?
हाँ, आप रिकॉर्डिंग स्टॉप कर
हाँ,
दो,
रिकॉर्डिंग क्लोज कर सकते हैं। और
काफी लंबा
ये जो जेमिनी सुन रहा है हमारी कन्वर्सेशन